Okay, so here's some R output. So it looks a little different. It has most of the same elements in it. So here they put the intercept, instead of calling it the constant, they call it the intercept. And they put it first instead of second. This is the variable name that Angela came up with. So again, that's sort of, you know, your choice when you're programming. You sort of call your variables what you want. And you also get the standard errors, and you get the t-tests for free. The f-test here, instead of being listed in the upper right corner like it is in the data output, it's listed at the bottom. But it's the same information. It basically gives you the value of the f statistic and then tells you the p-value at which, or you know, sort of the size of the test at which you would reject the null. And here, this is a very small p-value. So any traditional test, you would reject the null that beta 1 is equal to 0 here. Okay? And then you can even, this is, well, let me just go back for a second and note that the r squared of this regression is 0.41, okay? And if you're wondering what a 0.41 r squared might look like in a scatter plot, so this is a scatter plot of the variables and the fitted regression line through them, okay? And if you're curious about the particular variables, these are variables from the General Social Survey about attitudes on abortion and how they have sort of been evolving over the past couple of decades in the US. Okay, questions? Okay, so how do we interpret these parameter estimates? And in particular, how do we interpret the estimated coefficient on our x variable, this sort of beta 1 hat? Well, beta 1 hat is the estimated effect of y of a 1 unit increase in x. Okay? So the precise nuances of the interpretation are going to depend a little bit on whether we think that we've estimated a causal relationship or whether we think we've estimated something else. Okay? So the language you might use could be a little bit different, but this is the basic idea. This is how we interpret what beta 1 hat means. Okay, so let me show you. These are some data that I downloaded from, let's see, the ESPN website. I did this several years ago. So this is data involving the 2005 Major League Baseball season. And what I did is I downloaded the number of wins of each team and the attendance, the complete season-long attendance for each team, and wanted to see if there was some relationship between attendance and number of wins. Okay, so what did I do? I regressed attendance, that's my dependent variable, my y variable, on the number of wins that each team had. And we see here, based on this regression, that one additional win is associated, oh, and I should say the attendance was in thousands. That was the unit I used. So one additional win is associated with an additional 31,000 fans in attendance over the course of the season. Okay? So we might want to exercise a little caution to think that this is a causal relationship. We'll sort of get to that more later in the semester, but at least sort of this regression suggests that an additional win is associated with 31,000 fans in attendance, an additional 31,000 fans in attendance. Okay?